thank you very much, everyone, for joining us today. We are delighted to have you here, and we will be talking about plant counting. So this is one big topic that you're all excited about. So without further ado, we'll start with a quick introduction. My name is Joss Gillet, and I'm the R&D director at Hiphen. I've been at Hiphen for almost 2 years, and Alexis is the founder and CEO of Hiphen. So both of us will be taking you through the presentation today. The presentation will be done in 5 sections. So we'll talk about crops, we'll talk about UAVs, we'll talk about methodology, and we'll talk about Cloverfield, which is our online data platform for data processing, and we will have a Q&A session at the end. So we'll try to be very brief and straight to the point. So essentially the first message, if we start just very quickly about Hiphen, we are experts in plant diagnosis and measurements. This is what gets up out of bed every morning. And about plant counting, we know that it is very labor intensive. Traditionally, plant counting is very labor intensive, and this is one thing that has been solved in a way or improved thanks to high throughput phenotyping. So I'm sure you're all very familiar with that. And one thing that we are very proud of at Hiphen is to be part of CAPS, which is a research unit based here in the south of France, which is basically developing innovation in a high throughput plant phenotyping. So together with INRA, Arvalis, and other technical institutes, we work on these new solutions and new innovation, and we've published over 40 scientific papers. And here I just want to show you 2 quick papers that we published on plant counting, where this is probably two very complex cases that we try to solve. One is about here the ear density, so for wheat spike detection and counting. So we spend a lot of time and effort on investigating this topic, and the same for wheat stems, which can be detected and counted. So these are 2 papers that I wanted to highlight. You can see all of them on our website. And plant counting is effectively something that runs routinely in Cloverfield. So you will see proper and clear examples here of what Hiphen can do, but this is something that we are very familiar with, obviously. So before talking about crops, a quick few messages about what Hiphen's mission is in a sense, which will give you more context a little bit. So the first mission we set ourselves is to be bulletproof. And by that, we mean that we want to develop solutions that can adapt to different field conditions. So we don't want to have to change the algorithm, the engine of the algorithm, every time we encounter new specifications in the image required with drones. So this is the first point, be bulletproof. The second is about transparency. We want to make sure that we are transparent and give you a level of control on the fine-tuning of the algorithms. So we don't want you to think that this is a black box kind of solution. I don't know what's going on inside the algorithm. This is not the case. And we care a lot about being as transparent as possible with our data modeling and data processing. And finally, we care a lot about being agile and being able to allow you to scale. This is really the one of the big ambition at Hiphen, is to ensure that whether you have a one-off project or whether you have thousands of fields across the world, that we have the solution for you. So these 3 missions are essentially what is driving our choices in technology and solutions when it comes to plant counting. So with that, I'll pass on to Alexis, who's going to talk about crops and UAVs.
Thank you, Joss. So yeah, so the microphone and my turn. So basically, when we speak about plant counting, the big issue is actually, are we really wanting to count plants? And often, from our experience with our clients, we realize that sometimes it's more about counting plants organs than plants. And I'll try to illustrate that. By example, let's take a simple plant to count, which is corn. Corn, you can count it in two different periods, or at just after emergence, where you can take the stage from V3 to V7 on the number of leaves, and there you're able to count the number of small little plants. Or you can also try to count the tassels, and in both cases, one tassel equals one plant, or one little plant at the beginning of the stage at emergence equals one plant. This is not necessarily the case, by example, with wheat. So with wheat, at UMT-CAPT, we published a paper where we were counting wheat at emergence with UAV. Today, it's not fully operational because of resolutions of UAVs. We do favor phenomobiles or handheld system to count plants at this phase. But most often, the people, what they're really interested in is wheat spikes. And this wheat spikes, you can count it at two phase, or at earing, or after harvest by counting straws. And there, actually, one seed as wheat tiller, in one seed, you can have many spikes. And that's really important because it's not exactly plant counting anymore. We can take a third example, which is sunflower. In the case of sunflower, it's even more tricky because you can count plants at emergence, at least at the first phase of emergence, and there, well, one plant equals that one plant, but you also can count the flowers. And there's cases of ramification in sunflower, so it's not all the time. Generally, it's one flower, one plant, but sometimes when you have holes, or due to holes, or due to genetics, and often to both, you can have some ramification of the plant and have many flowers for just one plant. And so if you start to count the flowers, the heads, it might be the number of plants, or it might not be the number of plants. And actually at Hiphen, we try to count what is available to count in your pictures, in your drones acquisitions. And I think this is really something very clear to keep in mind because it can explain some errors you're having between manual counting and UAV-based counting. So once we said that, what are basically the main methods, or what is really important in your materials to be able to count? Well, from our experience, the real issue is resolution. What you want is to have as high resolution as possible and not necessarily as many wavebands as possible. We do believe RGB is enough, actually, and that multispectral does not add information specific for plant counting. Multispectral data does brings a lot of additional information for other traits such as chlorophyll content, biochemical content, stress, etc., but not necessarily for plant counting. Next slide. And when we speak about resolution, so the idea is to look a little bit at it. Well, more we have resolution directly in the acquisition, happier we are. So here we give an example of 1/3 of centimeter size pixel, and we can see that we see really well the corn in this application. Of course, when you reduce the number of pixels, so you reduce the resolution, we're still able to count, but it can become more challenging as we will start to confuse the plants you're interested in with, by example, the weeds, etc. We do have a PhD student, Kavya, that is working on super resolution in order to try to increase artificially the resolution when you're having a lower resolution. So those things are things that we're able to do. Yeah. So then once we spoke about resolution, the real question is, okay, but how do we manage with one UAV to obtain higher resolution? Well, it can be with altitudes of flights, but it's also and mainly about the camera's characteristics. So, okay, I will not go into full details into this webinar because in 20 minutes, that's really not the objective. We have to go into a deep course of how the sensors works and capturing sensors. But basically, there's three main things you need to take into account. The sensor characteristics. So what is the sensor size, the technology, the amount of pixels you're having, etc. And also the length, so the focal length. Am I having an open focal length or closed or narrow lens? And all the mechanical shutters, apertures, etc. you can add onto this camera in order to improve the resolution and the quality of the image. So once we said that, for me, my main question is, hey, but Alexis, this must be very expensive. Well, the answer is not anymore. It was very expensive 5 years ago, 5 to 10 years ago. Having good cameras with high resolution was a really challenging issue to have it cheap. Today, you're starting to have really nice drones with decent sensors on it. Here we gave the example of a DJI Mavic 2 Pro, which has a decent 1-inch sensor and Hasselblad camera, which is clearly decent. Of course, you have a lot of other drones and we have no shares on DJI, but it's just an example of let's say, cheap drones that makes plant counting affordable, at least when we buy the sensors. And so what do we propose in Hiphen? In Hiphen, what we propose is an end-to-end solution to help you through all the process of making plant counting. And the first process, well, it's choosing the good drone, or at least assessing if your drone is able to count plants and at what altitude and with what procedures. So that's what we call the SOPs, or standard operating procedures, which will help you being able to count the plants or the organs you need at the right time. Then we can help you also in data acquisition. So in France, we make the data acquisition ourselves. We work with some other providers worldwide, and we can, of course, train you, and that's the next slide. We are starting to train a lot of people in how to use our SOPs and how to use their drones in order to make to increase the quality of their plant counting. So that's a little bit the first big picture about what types of crops and what are the changes in plant counting. I will let now the hand to Joss to speak a little bit about the different methods we have to count plants.
Yep. Thank you, Alexis. So here really we are showing that when it comes to data acquisition, you can rely on Hiphen to accompany you all along all the step-by-steps that we can imagine. So this is important. So the second step when the data is acquired is bound data processing and method. So there are two big families of plant counting methods that we wanted to talk about today. One is what we call the handcraft methods and the deep learning methods. So essentially, there's only one method that can efficiently adapt to most of the cases the diversity that we will encounter in the field. And this is back to the mission that we talked about before about being bulletproof, being able to manage and scale and so on, all of this diversity. And this is really why we are investing a lot in these deep learning capabilities. So when we talk about handcraft methods, essentially we are talking about methods that imply mechanisms and machinery that line up different steps that will be chained, and things like segmentation and crop qualification and so on are a lot of different steps that are lined up next to each other. It's kind of a heavy machinery that has to be adjusted every time there is a new image condition. So when the lighting is changing, or when you face a new soil or new color, crop color, when you have a resolution change, or for instance, the weeds are becoming a challenge, then this is a very heavy machinery to adjust and adapt these handcrafted rules in these methods, and it's time consuming, and effectively what it means is that it's very difficult to scale. So we are not saying that this handcraft method is wrong, because quite often the processing time is quite fast, but it's very difficult to scale. So we really believe that deep learning is going to change the game when it comes to plant counting, mainly because it's allowing your experts to easily fine-tune the models. With our capped partners, we developed a methodology that allow your experts to really dig into the data that we label. So the plant features detection mechanism starts with data labeling, in which we use a software to color and highlight the plants, the objects we want to detect. So this is the kind of tooling that we can provide that will then be used to train the model. And if we are not happy with the results, we can easily and rapidly improve it. So this is what we call the human in the loop approach. And this is again important because this is back to the mission we mentioned earlier about being transparent. You have to know how the model was trained, and quite often you would end up training the model yourself or together with Hiphen. So this is pretty powerful. And deep learning is also allowing us to provide the detailed data validation. So it's not a black box, as we used to think a few years ago. Now we use different ways to validate. Here we are highlighted two of them. So visual truth is something we do quite often with our clients, in which we take the results of the data, the plant detection, and then we try to visually check that the machine did a good job. And quite often it's very hard to challenge the deep learning results. And the ground truth is obviously very relevant. The only tips that we wanted to highlight today about ground truth measurements when it comes to comparing deep learning results to that is three things. First, don't collect your ground truth measurements 2 weeks or two weeks before or after the UAV flight, because you're going to have discrepancies, obviously, as you can imagine. Be careful with what we call lazy operators, who are going to record the same value for all the microplots. It happened quite a few times for some of our clients, where you have one technician in the field recording the same number for every microplot. So there's a bit of data cleaning to do, and these checks are important. And lastly, when it comes to data validation, we are always talking about RMSE, so root mean square error, and relative RMSE, instead of using a simple R2. So these are things that we can help you with. Data validation, we are used to that, and without data validation, there's no point in doing deep learning in a way. So this is basically about the difference between handcraft and deep learning. And when we are familiar with that, then the data processing engine we have then automatically takes care of all the computing. So it lines up all the photogrammetry steps, all the way to activating the deep learning algorithms and so on, quality assurance and so on, all the way to the data validation tooling. So we have a platform that we call Cloverfield that allow you to view your microplots, inspect your data in a lot of details, download your data and analyze it, and that allows you to then be a lot more efficient with your applications, whether you're trying to predict yield or sort or assess the quality of your trials. Here is a view of the data platform, Cloverfield. So you've got your traits that you can select. You see your auto image, you can zoom in, click on a microplot, view your data per microplot, and there's a lot more behind it. But in a sense, This is our secure platform to analyze, to visualize, inspect in a lot of details your data. And this is something that for 2020 we are processing millions of microplots, for instance, across more than 12 countries worldwide. So this is pretty powerful. Alexis, over to you.
Thank you, Joss. So today we're doing all that, and I think the big question you all ask yourself is, plant counting must be today super expensive. I mean, with all this amount of technology and all that, I mean, and the answer is, well, fortunately, not anymore. So fortunately, we managed really to bring the cost down, to bring them so down that we're starting to be able to compete with manual counting and either being cheaper. This type of pricing is quite complex to explain in a webinar. So please, if you're interested, take touch with us and we will help you on how to do it, to make you quotation for the best. What we made sure for all our customers is it will always be cheaper to work with us than doing it yourself or with the data processing, with all the people you will need, or through manual counting. And for that, of course, it's easy for us to start by a free sample and to give you, so what we do generally is two things. We give you feedback on if the acquisition you already made are good or not, and then we make the plan counting. So now is phase of question and answer. Maybe because we said it would last only 20 minutes, I would like to give a last little message for the people that needs to have other business and other meetings in 5 minutes. It's just that we're making this type of webinar every week. And so please feel to subscribe for the next webinars. We will have a webinar speaking about disease, Cercospora disease for UAV. Another one speaking about plant senescence, which is an extremely important phase, by example, for rain filling. We will speak about a really cool Kaggle, so a really cool initiative that Hiphen is supporting, named Global Weed Challenge. So we will have someone from Arvalis and from INRAE that will explain us what is this challenge and how this can be a game changer in counting weed spikes in the future. And finally, today, because we're able to count plants, we're also able to follow them. And so that's what we do today with some customers, especially in sunflowers, and we're really making plant-to-plant monitoring and not anymore microplots to microplots. So we're able to identify each plant, to have a geologicalization each plant, and to follow the growth and the future of each single plant inside a microplot. And this is a really game changer work, and we went until genomic prediction with our clients, and we will be really happy to share all of that with you. So for all the people who are happy about just this short intro about plant counting, thank you. For the other ones, we will come back to question and answers, and I'm going to start to read some of the answers I've seen up to now, and of course I will follow them there. Joss will not be a help because it doesn't work on his side, so please apologize myself for the little time to read one after the other. So the first question we have is from Alexis Carlier. The question is, what is the lowest altitude possible? So the lowest altitude possible, there's two things to take into account to understand what is the lowest altitude possible. First, the device of the drone's capabilities, and the terrain. Is the terrain flat or is it with a curve? So now with the new drones, you don't risk anymore to crash the drone if you're having a small slope, as there's some controls with some sonar that are measuring the distance between the drone and the canopy. The other issues is about the opening angle and being able to stitch all the images. Today, we believe that being lower than 10 meters doesn't really make sense with a drone, and most of our SOPs are between 15 to 25 meters high. But once again, it really depends on the opening angle of your camera, of the number of pixels, and etc. So that was question 1. Question 2, Pedro Pardo was asking, what's your experience counting plants in sorghum, where you have more plant density than in corn, and at what stage? So actually, sorghum is a quite cool plant to count. Like with corn, there's 2 phases where you can count it. You can count it just after emergence. Indeed, the time you have to count it and to be able to split the plants is lower than in corn, but I mean, we still do that for some customers. And actually, what is mainly do at the same time with our customers and in the literature is counting heads. So, and sorghum heads are much easier to count than panicules in corn. So that's really the way we're doing it. Kevin was asking, has shadow an impact on plant counting accuracy? So Kevin, this is exactly one of the examples you were saying. Shadow is having a great impact when you're having what we call handcraft type algorithm, because you don't really know if it's soil, if it's green pixels. With deep learning, normally we're able to take this into account, and as long as the shadows doesn't allows us still with our eyes to see and to count the eyes with our eyes, we will be able to train algorithm very easily with a human in the loop approach to be able to count the plant nonetheless. So the answer is yes. When there's shadows is always more painful than when there's no shadows, but with the new methods is going to start to be less a pain than what it was before. Other questions. Kevin was asking, what is the lowest resolution allowed for plant counting, please? So up to now, the lowest resolution we're advising to our customers is 100 pixels by object you want to count. So you see 10 pixels times 10 pixels, it makes more or less 100 pixels. Today, we're having a PhD student working on super resolution, trying to lower the amount of pixels we need in an object to be able to count it. But I think it's something safe. So bigger your object, lower the resolution you can allow yourself. So we had Grelais that was asking, for plant counting, you don't use method of counting gaps. So the answer is no. I think gaps is quite used. I mean, there's some applications where gap is really relevant of counting. By example, when you're trying to detect gaps to sown again, like in grapes, etc. But still, it can be eventually still relevant to count gaps in some applications. So let's be very modest. This being said, I think today the new technologies allows us to count directly the organs of the plants and not just to assess for the amount of gaps, which allows us to be much more accurate. So it depends on the use cases, but if we can avoid, we prefer. Songli, will this video be online? Yes, we will put this video online in the near future. Yes, so Songli was asking another question about resolution, about 4 centimeter by pixel. 4 centimeter by pixel is a very, very low resolution. So no, I mean, generally we prefer having less than 1 centimeter per pixels in order to be able to count. But once again, if you have massive plant, like if you want to count trees, yes, of course, 4 centimeters per pixels is easily feasible. So then we have, should I use, which email should I use? So dear Songli, if you want to send us email, you can easily use contact at -plants.com. So this is easy to use. And then we have Enoch Mutanga asking us, is there no problem with weeds and shrubs when counting plant and using only RGB than multispectral camera? So the answer is, when you're having weeds and shrubs, it's always a pain. I do not think multispectral camera help that much to differentiate between weeds and real plants. What helps you differentiate it, once again, will be a conventional neuronal network type algorithm, so what we call deep learning, and it will allow you to split between the plants and the weeds by training. So we will have to do more labeling. And this, of course, is in more human-in-the-loop phase. That's why, and it's going to be in a couple of months, we'll present a platform where you can label yourself your images to improve what we are doing at Hiphen. But no, I really believe that for weeds and shrubs, resolution is much smarter than multispectral data that actually we don't really know how to use very well. So most of the time, the people that are using multispectral data didn't give, in my opinion, very convincing results. So that was basically all the question I've got. Everyone is saying thank you. It's 4:35, so I guess you all have things to do. And I'm really, really happy to meet you again in 1 week to speak about disease and Sarcospora. Thank you very much. Goodbye. Have a great end of the week. Stay safe with the confinement for most of you.
Thank you, everyone. Bye-bye.